Good morning, everybody, and welcome to Nixu's webinar on DevSecOps. I am Matti Suominen.
Yes, and I'm Matti Kesäniemi.
And we are here today to talk about DevSecOps in general, to give you some basic idea of what that means, and also how you can apply that in your own organizations. So we'll go through a little bit of theory at first, just to give you a basic idea of what we're talking about today, give you some basic ideas and concepts that some of you might know and some of you might not. And at the end of that, we start going through questions and also some topics about where deployments tend to go right, where they tend to go wrong, and so forth. So it's going to be hectic 30 minutes or so, but definitely drop in questions whenever you want, and we will be tackling those after 10 minutes or so, depending on how it goes. If there's any technical issues, whatnot, just let us know. We are testing out something new and let's see how that goes. There's always the potential for a demo effect to go horribly wrong. Apologies up front. So Ari, do you want to take us from this to some of the basics about what DevSecOps actually is?
Yeah.
And before you do, just one mention. So there's a functionality for entering questions to the chat. You should be able to see what's on the screen now. So use that to give us some questions, feedback, comments, whatever you want us to talk about, and we'll do our best to cover everything. If we cannot cover it during this half an hour, we will be following up with a separate presentation, blog entries, what have you. So, Ari, without further ado, give us the basics on DevSecOps.
Yes, I think it's important to define what we're talking about and give the context of the discussion. Half an hour is not too much time for discussing all of this, but
no.
Let's start with the basics and then talk about things that we have seen, what we are helping our customers to do this, and we have seen different teams, different environments, different approaches. So let's talk about how things work in practice and what doesn't really work and so on. But to start with the basic concept, so you probably know DevOps, so automating things as far as possible to get agile method for deploying and releasing stuff. But you also need to take security into account. And when you have things automated, you also need to automate security. So that's the basic approach that we are dealing with. And well, you have the dev side and you have the ops side. We are talking more about the dev side here today. And in the dev side, you have different kinds of scanners, basically, to ensure security in the whole pipeline. And the four main types of scanners are well, you are seeing them here with acronyms. I'll go briefly through these. So basically, that's a code scanning in other words. So you're just taking your source code, then scanning through that with a tool, getting results, and then dealing with those. You're only seeing the actual code. If you have something in your environment, in the configuration of your products or something like that, that probably is not shown in the code scanning results. Then there's DAST, dynamics testing. So then you're actually running the test environment, test system, and then attacking against that with tools. So with DevSecOps, it's automated attack, and they try to find all the places in the system where to attack and apply different kinds of attack payloads and whatnot. And that's really good for testing the whole stack of technology that you have. But obviously, you can't see all the things under the hood, weaknesses and things like that might be lurking there, or some special cases that require specific input or something.
Mm-hmm.
Then there's this IAST. This is a new kid on the block. So yeah, it's interactive application security testing, but I would say it's more like technology to observe your system when it's running, even without security scanning or kind of security attacks. You can just observe it being run with your functional tests, and it picks up all kinds of potential vulnerabilities, missing input validation and that kind of stuff.
So it's basically like somebody who is monitoring what the application is doing at any given time, spotting at the other end of the chain, rather than looking from the attacker's perspective. It's more like looking what the defenders are seeing.
Yeah. So that's quite interesting. And then finally, there's SCA, software composition analysis, which looks at your or the components that you are using from open source components, basically, and what are the vulnerabilities in those published vulnerabilities, and if it correctly detects your components, then it quite accurately can find all the vulnerabilities that are published in different databases. So those are basically the four main approaches for scanning, and you typically don't need all of these for one project, but you can combine, and each of these have different strengths and weaknesses.
So how do you see from the perspective of if somebody's just starting out, they don't necessarily have any tools, so they have some tools maybe in use. So where do you see it being easiest to start out? Are there some tools that are maybe easier to deploy or easier to use, or how do you see that going?
Yeah, obviously depends on your setup, but maybe the next slide would help in discussing this. So this is a kind of a typical case where you have on the left, you have your source codes and binaries, your test environments and whatnot. So basically your development environments. And you can plug in different scanners there with using your continuous integration system. For example, for code scanning, you can just have the continuous integration system to send the codes over to code scanner. And well, if you're using, for example, some cloud-based service for scanning code, then it's really easy to take it into use, because you just need to upload the code package, and then you get the results using API from that. So I would perhaps start with code scanning because it's easy and it gives you good results. Well, good in the sense that they are meaningful, but also you get typically a lot of false positives, which means that you get results that are not really relevant, or even worse, they are just like incorrectly identified. So they are not applying, or you get findings that are not really that severe as the scanner is saying.
Yeah, so context. You have to have some experience in running this before you start getting meaningful results out.
Yeah. If you start with the code scanning, then maybe another alternative or the next thing to do would be component scanning, because that's also relatively straightforward. You can just scan your repository or your build configuration and see what are the components and get the results. And as I said, they are typically quite accurate in finding the vulnerabilities if they just identify the components correctly that you are using and the versions.
Yeah.
But yeah.
And I guess also thinking about that, so there's been a lot of studies into how components are being used in different applications. So today it's really hard to find an application that isn't using some kind of open source components.
Yeah, definitely.
So from that perspective, if you don't have any idea of what you are using, that's a huge problem right there. So I think definitely an area that most people should cover somehow.
Yes, and actually if you think about your system, you have like 1% of the code is actually your code. Yeah. The rest is just frameworks and components and operating systems and whatnot.
Yeah, I've been telling people this number, and it's completely made up number, but usually it goes fine. So when I tell people that roughly 90% of whatever you are developing, whether it's a product, whether it's a service, whether it's just an IT application, roughly 90% at the very least is made by somebody else other than you. So it's not made by your developers, it's not made by anybody that you necessarily have any relationship with. This is not based on any facts, but usually when I say 90%, people just go like, I can buy that, makes sense. I think the real number is actually higher.
Yeah, I would say so. Actually, that is how we like it to be, because we don't want to write everything from scratch.
Sure.
Just using what we already have. So, so yes, starting with code scanning, component scanning, that's probably the best way to go. If you're adding dynamic scanning, then you are going to see issues with how to make that scanner see your system, depending, of course, what kind of thing you're developing. But typically, you need to be configuring this scanner a bit more.
So let's think about the picture a little bit more. So this is more like a really basic, I would say, starting point for most organizations. So we are thinking about a layout where there's a handful of tools being used. They are not necessarily used very consistently. So it's not like everybody's using everything. Would you say this is a reasonably accurate description of a company starting to use DevSecOps?
Yeah, I think, well, typically what we're seeing, people are using code quality tools like SonarQube. I guess pretty many are using that.
Yep.
And that's kind of the first step towards having a SaaS solution. It's really not a good SaaS solution as such, but you get the idea and you get the routine of looking at the results and so on. Because in picture, what we have here, the scanners, they can find things, but they are not really doing anything about those. They're just reporting those. So it's important that someone is actually looking at results and then acting on them. So and the good way to do that is to use Teams backlog or the product backlog of things. So put things that need to be fixed in that there as well.
So let me look into some of the questions we have here and start thinking a little bit more about what usually goes right and what usually goes wrong. And that should get us moving a little bit further. So I'll pick up some of the interesting ones. So how do you see, in our example picture here, we have a number of tools being offered. And of course, there might be different deployment models. So we might have a situation where the company is providing a number of tools and those are available to everybody. But it might also be that some teams, or maybe even all teams, have bought their own tooling and they're all paying for them separately and using different tools within the company. So do you see there being differences between a central model where it's all bought by the company and mandated by the company even in some cases? Or would you say that it's better to leave that to the teams?
Yeah. Well, obviously, it's good if the team itself, if they are taking these into use and looking for new tools and being excited about scanning and so on. So of course, that is a good thing. But in the long run, in bigger picture, it's better to have one, not necessarily one place, but one team that is handling all the tools because they have expertise about those tools. They are seeing how they perform with different teams, how the tools are performing, and can then configure, because you need configuring and you need tuning, for example, to get rid of false positives and so on. So definitely I would centralize the management of tools in one team or two teams, depending on what is your need, but not leave that to only to the teams that are using those.
So would you also say that there is a cost factor to this? So if you have a lot of different tools in different teams, then there's also a risk that there's a lot of spending going to waste. So somebody already has a good tool, but that's not being shared to other teams that could also make use of it.
Yeah, definitely. So and of course, when you have central space, you can share experiences. You get to know what works with what technology and what doesn't, and that's helpful. So you don't need to be, the team might be using the wrong tool for their technology.
So from the technology point of view, what would you say are the typical problems why things don't quite work out? So if we think about the technology first and then maybe go a little bit more into the process side of things.
Well, I've been mentioning configuration and tooling a bit already. So that's maybe the biggest thing, or one of the major things, that the scanner might not be seeing the target, especially when doing dynamic scanning. It might just skim the surface and then not really looking into the all the functionality that is there. Another big problem is of course false positives. I've mentioned that already. That I think it's mostly with it's the biggest in code scanning, but then when you're done kind of the first round of looking at results, then it gets easier because you're not getting the same results anymore.
That's fair.
Of course, when you have big systems, scanning those might take a long time. Dynamic scanning or even code scanning may take a long time to perform. And then if that is in your kind of critical path in the release build, then it's the thing. But of course, you can try to optimize that and of course do that nightly or schedule it so it doesn't interfere your other builds.
So you mentioned false positives now a number of times, and I think that's something that comes up with everybody who has tried any kind of security automation tool. And it's always, what do we do with the false positives? Obviously, if you cannot rely on your results, so if you're saying to a team that, well, here's something to fix, the team goes and does it, and that's not really a thing, and this keeps happening again and again and again. So I can see that being really frustrating. So would you like to share some ideas on how to deal with false positives?
Yeah, first I want to emphasize what you said, that it's really frustrating for the developers to see all those false positive things that are reported to them as like high severity findings, which are actually not. It's not something that they should be fixing. So it's really important to get rid of those, or at least minimize the number of false positives. And but how to deal with those? Well, the first scan, be it code scanning or dynamic scanning or something else, it's important to really address all the findings and categorize them. It takes time, but it pays off. When you have the scanner has learned that, okay, this finding in here is actually false positive, it's not going to report it again. So that obviously helps. And
so would you think a more central approach would work there? So how would you structure this in terms of a organization? So obviously one team can fix it in their own, and there can be somebody looking into that. But how about in the bigger picture?
Yeah, so especially if you have different scanners doing same kind of scanning across different teams, it kind of you have overlapping work. So one approach to dealing with false positives is actually using a kind of centralized repository for the findings, and that's actually what we call, or the industry calls, AVC. That's application vulnerability correlation. Maybe you can
so we can jump forward. So here's a picture of a slightly more complicated environment. So this is maybe slightly closer to what you would hope to see in the best case scenario. It's more complicated, has a lot more stuff going on, but at the same time, it's a lot more centralized and focused as well. So maybe you can give a little bit of an example of why this would make more sense for especially larger companies.
Yeah, so starting with false positives, AVC is of course helping with that, because what it does is as you can see from the picture, it collects all the findings in one place, in one system. The different scanners, those AVC tools, they can read a really large number of different scan results. So you get code scanning and dynamic scanning and IS and component scanning results in there, even manual testing results, if you will. And then it can see results from different scanners against the same system. So it can compare that, okay, the code scanning actually found this this finding in this file, and dynamic scanning found that kind of finding in the some URL, and you can map that, okay, these are actually the same thing, and that helps in false positives in kind of in the opposite way, that it can verify that this is actually a true positive finding. And regarding false positives, of course you can and maybe I would say you should classify or go through all the findings in the AVC tool, because then you get the database of findings, and you can also mark those false positives, so it can learn that, okay, these kind of findings are always false positives.
Yeah, and I guess you already mentioned earlier a little bit about how some tools are better at certain things. So for example, source code scanning does certain things really well because it can see behind what's obvious from the outside. So you are looking into the sort of insides of the application. But then when we think about scanning from the outside, you are not restricted by just looking at the code. You are also seeing the effects of the environment, the network around it, etc. So when you put together the findings from a code scanner and a dynamic scanner, you can sort of say that, well, in the code, this looks bad. And I can also see a similar effect when I try to test that functionally from the outside. So now I'm getting reasonably certain that this is a real thing. And I can also point to the part of the code that is saying, okay, here's the problem. So it's not just a vague problem that we are seeing somewhere, it's an actual problem in a specific location.
Yes, definitely.
One thing that I also want to highlight on this is that very often the problem with these kind of setups, especially for larger companies, when you start having a number of tools, you start having dozens, if not hundreds of teams, you start getting into this problem where it's actually getting tricky to follow up on who is doing what and are they actually doing it. So you buy a lot of tools, teams buy a lot of additional tools, then all of a sudden it's not so much that you are missing results. It's not like you rarely have this problem where you don't have enough results. It's just that the results are everywhere. All the teams are handling them differently. And some of the teams are maybe not even doing it at all. So maybe they bought a tool, but they just didn't feel like it, or they just didn't get anywhere, or they felt that the tool isn't really performing. So this kind of setup has also that nice side that the management or whomever it might be, the team leads or some central authority somewhere can go and check that, well, how are we actually doing on these scans? You know, are we getting results? Is this actually helping anybody? And are we actually solving any problems?
Yeah, that's actually quite typical problem that what we have been seeing in different organizations, because they have scanners, but really are not seeing, are they being used? What are the results? And even more importantly, are those results being addressed?
Yeah.
Is there anything getting fixed?
So let's jump into another interesting angle, and unfortunately we are today talking a lot about where people go wrong, but at the same time I think that through talking about where people usually go wrong, you can find a path to how to do it right. Because once you avoid a lot of the problems that people usually face, it's not necessarily smooth sailing from there, but it gets a lot easier. So we put together a list of things that you typically see which fail at different companies. So Ari, would you like to go through the basics of what we're talking about here?
Yeah, I think we have been seeing all of these. You see a nice flowchart where you are getting a false sense of security rather than actually improving security. And it can fail in different stages, kind of thing. So obviously you need to be scanning the projects in order to get any results. So getting visibility to what is being scanned and what is being scanned successfully, that's important. It's unfortunately it happens so that the developers are just ignoring failing scans when it gets into their way. So, and in that, of course, it helps when you have one team managing the tools, knowing how they should be configured and fixed.
And this might sound silly, and it might sound very accurate to some of you, depending on whether you've gone through this or not. But it's very typical when we start talking to companies, they say that they bought a tool or a handful of tools, and they sort of put them somewhere. They told people that, okay, we have now the tools, and there is an expectation that something starts happening. And more often than not, I would say that it doesn't. There might be like an initial burst of interest, and then suddenly people realize that nobody's actually scanning anything. So there was a feeling that we have all the tools and we spend a lot of money on the tools, but then you realize that nobody actually uses them.
Yeah, it might be that the configuration is failing. It's just not scanning what it's supposed to do, or it has a lot of findings. Many of those false positives, and developers are just like ignoring them because they can't handle it. So of course, someone needs to be looking at the results. In the first, you would begin with looking at the scan results and then getting those valid results to teams' backlogs, because the team backlog or product backlog is the way to actually get things done typically. If they are in some report or some other place, the team is not seeing them, they are not taking those into their planning and actual work schedules. So, and if you have ABC tool, for example, that helps because you can get the valid findings to backlogs.
Yeah.
And when you get that like nicely flown, then you can also do it so that the automated results get automatically to the backlogs when you don't have those false positives anymore.
And this is also one of those interesting things. Very often when we talk to teams, you get into these situations where somebody made the kind of mistaken assumption that by buying a tool that will scan things for you, you somehow fix a problem. There's an idea that, well, we invested now in security, or we told some security person that, do a scan. This also happens with traditional testing, of course. You do a penetration test and then you ask somebody, well, okay, we did a test, now what? And then the teams don't realize that that's actually when the real work starts. So at this point, we are just talking about a problem that we have. We are not actually addressing the problem at all. We need to know that the problem is there. That's the critical part, but we haven't solved any problems. So that's why the flow chart, as naive as it sounds, it's very accurate. So if you are not resolving your problems once you know about them, now you just have more problems. You didn't actually solve anything.
Yeah, I would say that even though setting up these scanners from technical angle, that might be troublesome. You might run into problems and whatnot, but it's still easier to get that done compared to get the people do what they need to do. And for that, of course, we need to utilize existing agile practices that teams are using, backlogs and CI setups and whatnot. So that's really important.
So we have roughly time for maybe one more question. Let me throw one that comes up quite often. So let's say we do all this good stuff and we have a DevSecOps setup running, we have all the tooling we can buy. So do we need any manual testing anymore? Can we just fire all the penetration testers and all the people, all the security people, just let the machine run its course? AI is coming and whatnot. What's your take on that?
Yeah, of course, manual testing, it's answering to a different question. Automated testing, that's help you to keep a certain good technical security baseline. So you don't have those easy vulnerabilities or those technical ones from components and so on. So you don't need to be testing those. But of course, manual testing is needed when you're looking at the business logic or typically the access control or that kind of things in the system, because automated tools are really bad at those. They can't understand the context of the system, the users, the use cases and whatnot. So definitely you need to have manual testing, but of course you can't have that every night. The automation does that tirelessly every night, but of course you still need to have manual.
Yeah, I think it's good to understand that maybe what automation does for you. If you think about from investment perspective, so are you saving money or losing money by investing in automation? So what's going to happen almost naturally is that once you run these scans for a while and you start picking up those problems during the development phase, so you are fixing things as you find them, that's not going to fix every problem. So there's still going to be these that you mentioned, for example, business logic. So somebody can steal money from the bank and the tool doesn't know it's a bank, so it cannot tell that problem to you. But at the same time, when you start doing the testing by a human, it's going to be a lot more useful, actually. They are looking at things that the machines cannot look at, rather than, reporting a ton of problems that anybody could have found at any given time. So I think a lot of the time, manual testing is, I wouldn't say wasted time entirely, but a lot of it is wasted because it's being spent looking into things that could have been found in 15 minutes.
Yes.
So you shouldn't involve a person to do something that a machine can do. Just save that for once you are actually confident that the tools are not picking up anything else. There's no reason for the human to come back and find the same things at maybe 100 times the cost.
Yeah, definitely. And of course, when you find things automatically, you can fix them right away. And it's an easy thing to do.
So we are about at the end. We only had 30 minutes, and it's a theme that we could most likely spend a week talking about and not really even scratch the surface. So at this point, we are thanking everybody. And if you have any questions that we didn't cover, I would assume that there's a lot of those. If you, for any reason, are interested to discuss more, just get in contact with us. And recording for this, of course, will be released, and we will be following up with some blogs and other content for you to browse. So this is one of those themes that is definitely picking up in the industry. There's a lot of interest and buzz around automating security in general. So definitely let's keep in touch. I have been Matti Suominen.
And Kesäniemi, thank you.
Thank you for this, and goodbye.